All right, let's do this next problem where they ask us to approximate the area of this function 2 over x squared. You can see that the function is a kind of hyperbolic actually, and we're going to be approximating this area from 2 to 10. First, we're going to use 4 rectangles, and then we're going to use, how many is this? 1, 2, 3, 4, 5, 6, 7, 8 rectangles. And so you can see that we're using left endpoints because the rectangles are touching on the left. So essentially all we need to do is find the area of these rectangles. Now you'll notice that this number of rectangles is going to be way off. We only want to find the area of this shaded part. So you can see that this approximation is going to be way off because we have all this extra unwanted area up here. As we use more rectangles, the approximation will get a little bit better. And the idea of the indefinite integral, which is the next section, is that if we let this limit go to infinity and have an infinite number of rectangles, that would give us the exact area. Now, it's kind of weird to think about because how can you add up an infinite number of rectangles that all have a width of 0? Because the width gets closer and closer and closer, and you get eventually a width of 0 for each rectangle. And the answer is, remember, we're not actually doing an infinite number of rectangles with a width of 0. What we're doing is we're approaching that. And that's the whole idea. That's what the limit is. We're approaching that, and as we continue and continue and continue to approach, the approximation gets better and better and better and better. Even though at the end state that we wanted, it doesn't really make sense to add infinite rectangles with 0 width. Anyway, let's not get bogged up in the philosophy of calculus. Let's just do what this problem is asking us to do. Our function is y equals 2. Oops, sorry about that. Our function is y equals 2 over x squared. And basically, we just need to find all of these heights. The width is going to be 2 every time for this first one. So this first one is going to be 2. I plug in 2 over here, which is going to be 2 times 2. So I'm going to go ahead and do this. What we're going to have is here we have 4 rectangles. So it's going to be base times the height of the first one, plus base times the height of the second one, plus base times the height of the third one, plus base times the height of the fourth one. And since the height is going to be since the base is going to be the same every time, I'm just going to factor that out. So 2 times h1 plus h2 plus h3 plus h4. So let's just go ahead and find these heights really fast. So we got, if I go ahead and plug in 2 here, I get 2 times 2 is 4. 2 fourths is a half, so 0.5. Or I guess I could have just looked at the graph. Next we'll plug in a 4, so that's going to be 4 times 4 is 16. 2 sixteenths is 1/8, which is 0.125. All right, did I do that correctly? Plug in 4 here. 4 times 4 is 16. 2 sixteenths, yep, that's good. Plug in a 6, we got 6 times 6 is 36. 2 over 36 is equal to approximately 0.055556. And then finally, the last one, we plug in an 8, is going to be 2 divided by 64 is 0.03125. So do that calculation, and we will have our first approximation. So 0.5 plus 0.125 plus 0.055556 plus 0.03125. So we get that this area is approximately equal to 711,806. Okay, so that's going to be the first approximation of this area, which we could then round accordingly. And it looks like, oh, never mind, I forgot to do one thing. I added them all up, but then I forgot to times them all by 2, right? Because we wanted to times it by 2. Sorry about that. So we get an actual answer of 1.4236. That's a lot better. So that's our approximation. Sorry, I forgot to multiply all of that by 2. There's our approximation, which does match my answer check. Okay, we're now going to add up more rectangles, and even though we're adding up more rectangles, we're going to expect that the answer is going to be a little smaller because we have a lot less of this extra area above. So this is going to actually be a better approximation of the area by doing this. Happily, the width of all of these is only 1, so I won't make that mistake of forgetting to multiply everything by 2 like I did last time, because it's just going to be a 1. So let's go ahead and do this approximation now. This is going to be 1 times, because the width of all of the rectangles is 1. Go ahead and plug in a 2, and like last time we got 0.5 plus go ahead and plug in a 3 this time, so it's going to be 2 over 9, which is 0.222, plus, I'll do one more 2, plus the next one, so that's 2 done, 3 done. When we plugged in a 4 last time, we got 0.125. Now let's plug in a 5. 2 divided by 25 is 0.08. Now let's plug in a 6. I think we did that last time, which was 0.05556. Now let's plug in a 7. 2 divided by 49 is 0.040816. Plug in an 8. We did that last time, and we got 0.03125. Plug in a 9. Are you having fun yet? 2 divided by 81 is 0.02469. And we're done. Don't do any more. We just did all of our rectangles, and so let's add up all of this stuff and times it by 1. 0.5 plus 0.2222. And we get an answer oops, did I leave off one of the numbers? You see how easy it is to make a mistake when you're doing this. I left off 0.08. Feels like I still left something off. 0.5, 0.2222, oh, that should have been 125. See how easy it is to make a mistake? This is why don't get too frustrated if you make an error. It's very easy to make a mistake when you're doing this. I've taught calculus maybe 6 semesters by now, and you can see that even I make mistakes with these calculator entry things. We get an answer of 1.0795, which is the correct answer. So notice this approximation is better to the true area. And what we can do is actually do an antiderivative to get the exact area. So here's what it would look like if we wanted to find the exact answer. So for your homework, these are the 2 answers they're looking for. Here's the answer if we do it exactly. What we do is we say the integral from 2 to 10 of 2 over x squared. Now it's okay if you don't follow all of these steps. I will explain this more in the next section. Dx. So we know that the antiderivative of this is the integral from 2 to 10 of 2x to the negative 2 dx. Okay, so notice that's, and so now we can take the antiderivative. That's going to be 2x to the negative 3 divided by negative 3. That will be the antiderivative, and we're going to evaluate that from 2 to 10. That means we do 210 to the negative 3 divided by negative 3 minus 2 times 2 to the negative 3 divided by negative 3. And so those 2 minuses are going to become a plus. Again, if you don't follow any of this, don't worry. We're going to explain it in the next video. We're going to explain it in the next video. Let's do this. 2, I'm going to move the 10 to the 3 down. So negative 2 divided by 10 to the 3, which is just 1,000. Times 3, oops, try that one more time, 2 divided by 3,000, and I need this to be negative, plus 2 divided by 2 times 2 times 2 is 8, times 3 is 24. Now something went off there. Oops, this one should have been, no? So it looks like our approximation is still quite a bit off. Let me double check this and I'll come right back to you in the next video.